Today we're going to be talking about the mean of a Poisson distribution. We're going to calculate the mean by using that the expected value, which is the mean, is the first derivative of the moment generating function evaluated at 0. And below, we've written down the moment generating function, which I've then written as a composite f of g of t. So to compute this derivative, we have to use the chain rule. So it becomes f prime of g of t multiplied by g prime of t. Okay. Now the derivative here of f is itself, the exponential has that property, but the derivative of g of t with respect to t, the derivative k to the t is itself, but the derivative of minus k is 0 because it's a constant. Okay, so using this, we get that it's f prime, which is e to the t composed with g of t. That's just the original function itself, e to the k times by e to the t minus 1 times by k times e to the t. Now we're going to evaluate this at 0, and we're going to get e to the k times e to the 0 minus 1 times k times e to the 0. Remember, e to the 0 is 1, so this becomes 1 minus 1. So that is going to give us e to the 0 times by k times by 1, because e to the 0 is 1. So this whole thing is equal to k, and that is the mean. Okay. Now, one other thing that you can show is that the variance of x is also k, and that's the expected of x squared minus the mean squared. We calculated half of this, that is the mean. What you have to do is calculate e of x squared, and I'm going to leave that as an exercise.